Welcome to lesson 3-4. We'll be starting out with rectangles. Now that we've talked about parallelograms, we already know the properties of parallelograms. Lesson 3-4 will talk about special types of parallelograms. The first one that we're dealing with is a rectangle. Rectangles are parallelograms with 4 right angles. So the key word right here is they're also parallelograms but with 4 right angles. If we're looking right here, there's my right angle, my right angle, my right angle, and there's the other one right there. So because a rectangle is also a parallelogram, all these properties right here are true for a rectangle. Opposite sides are going to be parallel. Opposite sides are going to be congruent. There's my opposite sides that are parallel. Opposite sides that are congruent. Opposite angles, these two right here, would be congruent. Consecutive angles, these two angles right here, are going to be supplementary. And then if we draw the diagonals right here, see if we can draw it. Draw a diagonal right here and a diagonal right there. Those two diagonals would bisect each other. That means this is congruent to this, that is congruent to that. So because a rectangle is a parallelogram just with 4 right angles, we know that all these properties right here are also going to apply for a rectangle. Now we're talking about special properties that are special to rectangles. Now here's one theorem. If a parallelogram is a rectangle, then the diagonals are going to be congruent. If you remember in parallelograms, the diagonals weren't necessarily congruent. But for rectangles, AC is going to be the same length as DB. Now, because AC and DB are the same length and they bisect each other, you're going to end up with 4 isosceles triangles. You have this top one right here, the right one, the bottom one, and the left one. All those are isosceles triangles. Remember, isosceles are just triangles with at least 2 equal sides. At least 2 equal sides. Now, the converse of this theorem is just if the diagonals of a parallelogram are congruent, then that parallelogram is a rectangle. So whenever you know that you have a parallelogram and their diagonals are the same, then that parallelogram would be a rectangle. Here's just a couple of examples that uses the properties of rectangles to solve problems. We're looking right here, if AE is 3x plus 2 and BE is 29, find the value of x. We know that AE is going to be congruent to BE because AC is congruent to BD, and then they bisect each other. So we know that this would be congruent to that, this would be congruent to that. So to solve for x, you're just going to end up with AE is equal to BE, which would mean you're going to solve 3x plus 2 is equal to 29. You work that out, x equals 9. Now if AC is 21, then how long would BE be? Well, if AC is 21, and we know that BD is the same as AC, then BE, which is half of AC, would be 10.5. Now, if angle 1 is 4x, there's my angle 1 right here. That's the angle. Angle 4 is 2x, this one right here. Find the value of x. Remember that for this one right here, we have an isosceles triangle. So that means that if this one is 4x and this one is 2x, this other angle right here would also be 4x. So now to solve for x, you're going to end up with 4x plus 4x plus 2x. Remember, we're dealing with triangles, and triangles always add up to the interior angles of a triangle always add up to 180 degrees. So using that, we can solve for x. X ends up being 18. Lastly, if we have the measure of angle 2 is 40 degrees, so this one right here is 40, find angle 1, angle 3, and angle 4, 5. So if we know this is 40 degrees, we know this is a right angle because we're dealing with rectangles. So this one right here, angle 1 would be 50. Angle 3 would be congruent to angle 2 because you have an isosceles triangle. Angle 4, if this was 50 and this is 50, angle 4 would be 80 because you have another isosceles triangle right there. Here are my base angles. They're the ones that are congruent. If this was 80, this is a linear pair right here, which means it adds up to 180. So that would make angle 5 100. And lastly, angle 6. If this was 100, angle 6 and this angle would be congruent in this isosceles triangle. So if this is 100, angle 6 would be 40. So that's how we use the properties of rectangles in order to solve problems like these ones. We're continuing lesson 3-4. Now we're going to deal with rhombi, plural of rhombus, and squares. Just like a rectangle, a rhombus is also a parallelogram, but rather than having 4 right angles like a rectangle, a rhombus is a parallelogram with 4 congruent sides. Looking at this figure, here are my 4 congruent sides. Since a rhombus is also a parallelogram, all these are going to be true to a rhombus. Oops, and I can't spell true. See if we can undo that. And it won't let me undo it. All those would be true for a rhombus. Opposite sides are going to be parallel. So these 2 sides are parallel. These 2 sides are parallel. Opposite sides are congruent. We already know it's 4 congruent sides. So those 4 congruent sides are congruent to each other. Opposite angles are congruent. This 2 and this 2 are congruent. Consecutive angles add up to 180 because they're supplementary. And then the diagonals bisect each other. Rhombus also have special properties that is unique to rhombi. So right here, one of the properties is the diagonals of a rhombus are perpendicular to each other. You can see right here, here's one diagonal, and then here's the other diagonal. That right there shows you that the 2 diagonals are perpendicular to each other. Now, each diagonal of a rhombus, aside from being perpendicular to each other, they also bisect opposite angles. So this diagonal bisects this big angle right here and this big angle right here. This diagonal bisects this big angle right here and this big angle right here. You need to remember that these 2 properties for rhombus because it'll be useful when we're dealing with problems involving rhombus. So here's just an example of a problem involving a rhombus. You have a rhombus ABCD. So here's ABCD. That's a rhombus. Now we're trying to complete all these statements right here. If AB is 9, we know that AD is also 9. Remember, we are dealing with rhombus, so all the sides are congruent. Now, if angle 1, which is this one right here, is 65 degrees, what would angle 2 be? Remember that the diagonals bisect each other, so this segment or this angle right here would have the same measure as this angle right there. So angle 2 will end up being 65 degrees also. Angle 3, we know that the diagonals of a rhombus are perpendicular to each other. So angle 3 would be 90 degrees. There's our 90 degrees. Now if angle ADC, this big angle right here, is 80 degrees, then what's angle DAB? Those two big angles right here, these two big angles right here, are consecutive angles. They're still supplementary to each other. So if this is 80 degrees, this would be 100, so that when you add those two together, they equal 180 degrees. Lastly, if we have angle 1 is 3x minus 7, and angle 2 is 2x plus 3, what would be the value of x? We know that AC, segment AC, bisects this big angle DAB. So that means the measure of angle 1 is going to equal to the measure of angle 2. So you're going to end up with 3x minus 7 is equal to 2x plus 3. Now it's just a matter of algebra. You're going to end up with x is equal to 10. So that's how we use those properties of rhombus to solve these kinds of problems. Now we're going to look at squares. A square is a parallelogram with 4 congruent angles and 4 congruent sides. So with a square, you end up with a parallelogram that is both a rhombus because of the 4 congruent sides and a rectangle because it has 4 congruent angles or 4 right angles. So now we know that in this diagram right here, these are all right angles and these are all congruent. So a square is a parallelogram that is both a rhombus and a rectangle. Because it's a parallelogram, a rhombus, and a rectangle, squares have all these true about itself. Opposite sides are parallel, so these two sides are parallel, these two sides are parallel. 4 right angles, 1, 2, 3, 4. 4 congruent sides, just like a rhombus, 1, 2, 3, 4. Consecutive angles are supplementary. These 2 angles are supplementary. These 2 angles are supplementary. This 2 and this 2. Diagonals are congruent. This diagonal and this diagonal are the same length, just like a rectangle. Diagonals bisect each other. That just means that this, and this are all congruent to each other. Diagonals are perpendicular because we're dealing with a rhombus. So this would be right angle right there. And then each diagonal bisects a pair of opposite angles. That means this angle is bisected to 45 and 45, 45, 45, 45, 45, 45, 45. So note that because a square is a parallelogram that is also a rhombus and a rectangle, all these properties are going to be true for a square. So now here's just some examples so that we can use those properties of a square. We're given square ABCD. So here's our square right here. If AB, segment AB is 10, we know that segment AD and segment DC and BC are all going to be 10. Remember that a square has 4 congruent sides. If segment CE is 5, then we know that segment DE is also going to be 5 because AC and BD are congruent to each other and then bisect each other. So this half is going to equal this half right here. Angle ABC, this angle right here, that's going to be a right angle because you're dealing with a square. Angle ACD, this angle right here where angle 6 is at, that's going to be 45 degrees because AC bisects that 90-degree angle. Bisect means just cuts it in half. Lastly, we have angle AED. Remember that with a rhombus, just like with a square, your diagonals are perpendicular to each other, so that would mean it's 90 degrees. Here is assignment 3-4. make sure you finish viewing this lesson before you go to the web page to complete assignment 3-4. You don't need to copy down any questions. All the questions would be on the web page. Make sure you type this in the address bar. That's where you will find assignment 3-4. Continuing lesson 3-4, now we're going to take a look at trapezoids and kites. Now we get to the part where we are not dealing with parallelograms anymore. Earlier we dealt with rectangle, square, and rhombus. Now trapezoids are quadrilaterals. That means they have 4 sides. But the key to them is they have exactly one pair of parallel sides. If you're looking at this diagram right here, this side right here and this side, those are the exactly one pair of parallel sides that we have for trapezoids. The parallel sides are called your bases, and the non-parallel sides are called your legs. You can see right here, these are my bases, and then this two right here, the non-parallel sides, those are my legs. Now, what we're going to kind of focus on is dealing with trapezoids that are isosceles trapezoids. That just means that the legs of your trapezoids are going to be congruent. So this length right here is going to be the same as this length right here. So trapezoid is no longer a parallelogram. It's just a quadrilateral with exactly one pair of parallel sides. The parallel sides are called bases. The non-parallel sides are called legs. Now we're going to look at isosceles trapezoids, trapezoids with congruent legs. So here are some properties of isosceles trapezoids. Both pairs of base angles of an isosceles trapezoid are congruent. That means that angle A is congruent with angle B. So these two are congruent. Those two are my base angles. And then angles C and D are also congruent to itself. Those two are two base angles right here. So this pair of base angle, C and D, and this pair of base angles, A and B, are congruent to each other. You can see right here, A is congruent to B, angle D is congruent to angle C. Now the other property of isosceles trapezoids are their diagonals are congruent. So that means AC has the same length as DB. So diagonals of isosceles trapezoids are congruent to each other. Before we move on to kites, we're going to talk about mid-segment or median of a trapezoid. A mid-segment of a trapezoid is just a segment that joins the midpoints of the legs. So here are my legs. There's my midpoint. There's my midpoint. You can see that that's congruent. That's congruent. So there's my midpoints. If I connect this midpoint to that midpoint, this segment right here, that's the median or mid-segment of a trapezoid. Now, the mid-segment of a trapezoid is also going to be parallel to the bases. So all three segments right here are going to be parallel to each other. Now, what makes the mid-segment special is the measure of the mid-segment, the length of this mid-segment right here, is actually half the sum of the length of the bases. So if I add B1 plus B2 and then multiply that by a half or divided it by 2, then that would give me the length of this median or mid segment. That's a key formula that you need to remember. Here's just a quick review of the quadrilaterals that we've discussed. We've talked about parallelograms. Right under parallelograms, you have your rectangle and rhombus. Then right after that level, you have your square, which is both a rectangle and a rhombus. Parallelogram, two pairs of opposite sides are congruent. Now with trapezoids, you only have one pair of opposite sides that are congruent. And under the trapezoid, you have your isosceles trapezoid. That just means that the legs of your trapezoid are congruent. Now we are at the end. We are looking at our last quadrilateral, which is our kite. Kites is just a quadrilateral with exactly two pairs of congruent consecutive sides. That's the keyword right there. The keyword is consecutive sides. So with kites, it's not the opposite sides that are congruent to each other, it's the consecutive sides that are congruent. That means it's this side right here and this side, or that side and that side. So whenever you're dealing with a kite, there's certain special properties that kites have. One of the properties is that the diagonals of a kite are perpendicular to each other. That means that segment GJ and segment FH are going to be perpendicular to each other. There's our perpendicular symbol, there's our 90-degree angle. Another property of a kite is only exactly one pair of opposite angles are congruent. Angle G is congruent to angle J. We don't know that about angle F and angle H. Just only G and J are congruent to each other. If you can see, angle G is between the two sides that are not congruent to each other, and angle J is also between the two sides that are not congruent to each other. So only that pair of opposite angles are congruent with a kite. Just a couple of terms here. The vertex angles are the ones that are made up by the congruent sides. You can see this congruent side and this congruent side makes up this angle. That's your vertex angles. This is a congruent side, this is a congruent side to each other. They make up this other vertex angle. The non-vertex angles, those are your pair of opposite angles that are congruent to each other. Just a couple of practice or examples with kites. You can see right here we are dealing with kite ABCD and we are trying to look for its perimeter. Knowing that two consecutive sides are congruent to each other, if this is 12, if BC is 12, DC is 12. If AD is 20, AB is 20. So now that we know all the side lengths, the perimeter is just adding up all the sides, and you're going to end up with 64 centimeters for the perimeter. Now for this one right here, this one's a little bit more difficult because you're not going to find X first. You're actually going to find Y first. The opposite non-vertex angles are the ones that are congruent to each other. So if this angle is on 146, angle Y would also be 146. Now, since we are dealing with a quadrilateral, a kite is a quadrilateral, we know that all the angles, all the interior angles should add up to 360. So that means 146 plus 47 plus 146 plus X should add up to 360. If I know three angles, I'm looking for one. I can add up these three angles, subtract that from 360, and that would give me the measure of angle X, which in this case is 21 degrees. We have now come to the end of lesson 3-4. Just a reminder, assignment 3-4 is in the middle of the video. Make sure you know where to go, what web page to go to, and you're actually going to put all your answers on that web page. Good luck, have a safe 2 weeks off, and be safe.